Hey space explorers, and welcome back to Earth and Space. Today, we're taking a deep dive into one of our closest cosmic neighbors, but one that often gets overlooked in the shadow of the great Andromeda Galaxy. We're talking about the Triangulum Galaxy, also known as Messier 33, or M33. It might be smaller and fainter than its famous siblings. But M33 holds profound secrets about how galaxies like our own Milky Way come to be. So buckle up as we journey about 3 million light-years away to uncover what this understated spiral galaxy can teach us about cosmic evolution. When you picture a grand spiral galaxy, you probably imagine a brilliant, star-packed central bulge, a dense core from which beautiful spiral arms unfurl. Both the Milky Way and Andromeda fit this description perfectly, but M33 breaks the mold. It's what astronomers call a pure disk or bulgeless galaxy. It lacks that massive, concentrated center. And this is exactly what makes it so fascinating. The absence of a central bulge isn't a flaw, it's a clue. It tells us that not all spiral galaxies form in the same way, and it challenges our assumptions about galactic construction. So, how does a galaxy form without a central bulge? The prevailing theory is that these bulges are the result of violent, chaotic mergers between galaxies early in their history. These cosmic collisions stir everything up, flinging gas and stars toward the center to create a dense, spherical hub. M33's pristine, bulgeless structure suggests it has lived a much quieter, more isolated life. It likely avoided major mergers, allowing it to develop more peacefully. Its formation was probably a much more gentle process, dominated by the steady, slow accumulation of gas from the cosmic web. The vast filaments of matter that stretch across the universe. By studying M33, we get a clearer picture of the fundamental ingredients of galaxy formation. Without the confusing aftermath of messy mergers, we can observe the pure interplay of gas, gravity, and rotation. We see how a rotating disk of gas can slowly condense under its own gravity, fragmenting into brilliant blue star-forming regions that beautifully trace its spiral arms. M33 is like a simplified, clean room experiment for galaxy evolution. It's a natural laboratory that allows astronomers to test their computer simulations and theoretical models on a less complex system. If a model can't accurately reproduce a simple galaxy like M33, it certainly can't be trusted to explain more complex ones like our own. For instance, the distribution and motion of stars and gas in M33 provide critical data for understanding dark matter. Every galaxy is thought to be embedded in a massive, invisible halo of dark matter, and its gravity is what holds the galaxy together. In a galaxy that has undergone many mergers, the dark matter halo and the visible matter can get all mixed up, making it hard to study their relationship. But in a relatively undisturbed galaxy like M33, astronomers can more easily measure how the dark matter halo influences the galaxy's rotation. This helps refine our models of this mysterious substance that makes up about 85% of the matter in the universe. Furthermore, M33's simplicity also helps us understand star formation itself. It's teeming with enormous clouds of hydrogen gas, the raw fuel for new stars. In fact, it's one of the most actively star-forming galaxies in our local group. We can see stellar nurseries in incredible detail, watching how massive, hot, young stars light up their surroundings and trigger subsequent generations of starbirth. It shows us that you don't need a chaotic, violent environment to have a thriving, star-filled galaxy. Sometimes a slow and steady process is just as effective, if not more so. Ultimately, the Triangulum Galaxy teaches us a vital lesson. The universe doesn't have a single blueprint for creation. It evolves by exploring every possible path, from the colossal merger-built ellipticals to the grand bulge-dominated spirals, and the quiet, elegant disks like M33. Each galaxy tells a unique story of its past. And sometimes, as M33 proves, the most profound answers don't come from the biggest and brightest objects, but from the quietest, most unassuming systems. They reveal the fundamental rules of the cosmos in their purest form. It's a beautiful reminder that there's always more to learn, and that every single object in the night sky has a story worth telling. What other cosmic mysteries do you think are hiding in plain sight? Let me know in the comments below. Thanks for fueling your mind beyond limits with us today. If you enjoyed this journey to the Triangulum Galaxy, be sure to hit that like button and subscribe to Earth and Space for more deep dives into the wonders of our universe. We'll see you in the next one.